Welcome to the 2023 Update webinar, which is brought to you by the Australian Fungicide Resistance Extension Network, also known as AFREN. I'm Dr. Anna Sharikriker, AFREN Coordinator, and in this session, we are joined by plant pathologist Sara from SARDI, the South Australian Research and Development Institute. And we will also be later joined by fungicide resistance expert, Dr. Fran Lopez from the Centre for Crop and Disease Management at Curtin University. Our experts will be presenting us with an update on key diseases of pulses, specifically botrytis grey mould, I hope I've said that correct, in lentil crops, and chocolate spot in faba bean. We hope to hear more on what the risk is for disease development in these crops and how to apply best management practices to reduce the incidence and impact of these pulse diseases. If you've joined us before, I'm sure you are all aware of AFREN, but for a quick recap of what we do, as a GRDC-supported initiative, AFREN delivers a platform of up-to-date resources and information directly to Australian growers, agronomists, and advisors. These resources can be found at the site afren.com.au and includes a fungicide resistance management guide, regionally specific workshops, fact sheets, webinars such as this one, podcasts, updates, and more. AFREN engages with top plant pathologists and extension and communication experts in the field so that we can keep you alert to the increasing problem of fungicide resistance, particularly in grain crops. We hope that by arming you with this knowledge, you will feel more confident with making informed decisions on best management for crop success now and in the future. So for a bit of housekeeping, if you do have a question during this webinar, please drop it into the Q&A box on your screen, and we will aim to address all of your queries at the end of the presentation session. So please do, even if it's something that you think of during the session, just pop it there and we will get to that at the end. So without further ado, I'm going to now hand you over to Sara and then Fran later on, who will guide you through these pulse diseases and their management. Thank you, Sara.
Thanks, Sheree. Thanks, everyone. Good day to you, wherever you might be joining us from. I am joining you from Ghana country, so I just wanted to pay my respects to leaders past, present, and emerging from where we're coming from today. So, I just accidentally went back one. Okay, what I would like to start today's webinar with is the integrated disease management best practice recommendations for management of foliar diseases in pulses. And yep, there are a lot of words on this slide, but I will step you through it. And I think you'll see that by the end of today's webinar, that this IDM best practice recommendations, that they're basically the same types of recommendations that the AFREN network recommend for managing for fungicide resistance. So for pulse crops, we recommend a 3 or 4 year break between crops of the same type. That allows the inoculum that might be born on the stubble or perhaps in the soil to degrade over time. Also, we encourage you to grow less susceptible varieties and to review the National Variety Trial disease ratings on an annual basis. And I'll speak about the National Variety Trial ratings for botrytis grey mould in lentil and chocolate spot in faba bean during my talk. So the next thing that growers can do as part of managing for foliar disease is to make sure you're sowing clean seed. And if it's not possible to use clean seed, we know that last year was a really big year for disease, then a seed treatment will offer around 4 to 6 weeks protection to that emerging seedling. That helps to reduce the inoculum load going into the season and gives the crop the best chance of establishing well. The other recommendation there as part of an early management approach is to avoid sowing near the previous year's pulse crop. And that includes your neighbour's stubble. And I think this is probably one of the steps that has been will be the most challenging this year off the back of last year's exceptional disease year. By avoiding sowing near a previous year's pulse crop, you reduce your risk of disease being liberated, pathogens being liberated out of that stubble and affecting your crop. So in season, make sure you're monitoring your crops early for signs of disease. That gives you the best opportunity to be proactive with your foliar fungicide strategy. And make sure you have your foliar fungicide strategy planned early in the season, which will be quite unique to each grower's situation. So there isn't really a one size fits all approach, but there are some guidelines that I'll walk you through today around what you could do. So your foliar fungicide strategy should certainly include mixing and rotating fungicide groups, and I'll talk about that, why that's important later on. Make sure you're applying your fungicides ahead of a rain front if the disease is present or the risk is there. I've just had a brief power outage in the building. I hope I can still be heard. Sheree, can you just nod? Yep, great. Okay. So, sorry, the lights just flickered. I just didn't want to make sure I hadn't disappeared. So then with pulse crops, we have a critical plant growth stage called canopy closure. So this is when the plants start to grow their foliage and the plants are starting to grow over each other and you can't see the soil below. And this stage is really important for many growers, especially in the medium and high rainfall regions, because a pre-canopy closure spray will protect the base of the plant before that canopy is closed over and before the fungicide can't penetrate below that those parts of the plant and the crop. And then consider applying a potting spray to protect the developing grain. That's particularly the case where we have a wet spring or where we've got susceptible varieties that are sown. We're getting towards that. When we get towards the end of the season and we've got that grain developing in the pods, we want to protect that grain and make sure we don't end up with seed staining or shriveled seed, which can affect both the quantity, so the yield, and your quality of the grain at receival. And then, of course, in any season, you need to consider the economics of your continued disease management strategy and what the crop end use might be. And that means that our withholding periods and MRLs come into play. Also, make sure that you're reporting any disease symptoms that you see to your state pathologist. So that would be to myself in South Australia. And for Victoria, that would be Josh Fanning over in Agriculture Victoria. So let me move on now to what we were seeing last year. So the 2022 season was characterised by this above average rainfall. And that was, I guess, what we were seeing last year is part of the reason that this particular webinar was proposed, because we know that growers had huge challenges in managing botrytis grey mould in lentil and chocolate spot in faba bean. And this presented a risk for disease management in this season, as well as some serious concerns about the risk of fungicide resistance developing. So for those of you that haven't seen this before, it's a rainfall decile map. It's specifically for spring in 2022. And you can see there that we had a decile 10, a very much above average or even the highest on record rainfall through spring for most of the grain growing regions in Australia, and certainly so for the southern region. And this was really a significant driver of the disease that we saw in lentil and bean crops in 2022. So as I've already alluded to, 2022 was really an exceptional year for foliar disease across all the pulse growing regions. And it was really tough for growers to manage for a couple of reasons that I'll talk about. So I'm just showing you there on the left, if you've not seen these diseases before, botrytis grey mould on lentil, you can see all of that brown necrotic material, the crop has collapsed. And then that's on the photo on the left. And then the photo on the right, we've got chocolate spot and faba bean. And I'm not sure if you can quite see it in this image, but that crop has started to lodge and fall over and the plants are starting to lie down on top of each other, which not only makes managing disease very difficult, but would have made harvest a challenge as well. So one of the big challenges that growers faced last year because of that persistent rainfall was getting that timing of their fungicide application done well. So there were very few dry days for growers to access their paddocks, and that created issues with paddock trafficability, either via the spray boom, or perhaps there weren't dry days for the spray plane to go out and spray, or the spray plane's availability wasn't there. We know a lot of growers had issues with mistimed sprays, so that fungicide didn't go out ahead of a rain event, for example, and they might have applied it once the rain had come, or they might have missed sprays entirely. And whilst there were some stories of growers who had sort of managed to tick all of those boxes and not done very well with their disease management because of the situation. Some growers who were able to time their sprays well ahead of rain events, they did fare quite well throughout the season, so it's not all doom and gloom. Some data that SARDI collected in a small disease survey we conducted in 2022, just specifically for beans, showed us that it was pretty common for growers to be applying at least 5 or 6 fungicide applications across the season, but I have heard some anecdotal reports of many more than that going out. And so that certainly creates a concern for fungicide resistance development. Now, that particular concern for control of chocolate spot and faba bean did prompt an emergency meeting called by the grains producers of SA late last year. I think it was October or November, because of the concern about just growers not being able to control chocolate spot. And, you know, is this fungicide resistance emerging? Is there another matter that we need to talk about? And what kind of information can we give the industry? We had the faba bean breeder Sam Catt join that meeting, some pulse pathology experts and expert agronomists. Fran attended that meeting as well with some other fungicide resistance experts. And essentially the conditions last year were just so highly conducive to disease that many growers we weren't able to effectively control because of that persistent rain event. It was just really conducive for grey mould and chocolate spot. So what are these diseases that we're talking about? We have botrytis grey mould. There you can see a close-up photo of these grey lesions on the lentil leaves, and then the reddy brown sort of chocolate covered spots that are quite scattered across the faba bean leaf on the right, and some more lesions that are coalescing. Now, these diseases are both caused by fungal pathogens, both by botrytis cinerea and botrytis fabae. And these are necrotrophic fungal pathogens. So what they do is they kill their host plant cells ahead of their invasion, and they use the contents of that dead plant material to support their own growth. Now, optimal conditions for both of these diseases I've listed there on the slide are generally mild conditions, so sort of 15 to 25 degrees. Usually what we start to see when it starts to warm up in spring. However, we know these diseases can develop more slowly under cooler conditions, and they can kind of tick along quietly before we start to get warmer sort of spring environment. Then the other condition, these are fungal pathogens. They like a lot of moisture, so high relative humidity can really promote these diseases. So that can come in the form of persistent rain, mist, fog, dew, or high soil moisture. And that was certainly the case that we saw last year with pulse crops that were really well established once they'd achieved canopy closure. We get that microclimate under the canopy with that really high soil moisture, promoting those fungal diseases down underneath the plant material. So a bit of plant pathology 101, and I wanted to show you the pathogen life cycles for both of these diseases. And I'm putting both of them on the slide here, but I'm going to talk you through them because there's a lot of similarities in these diseases, and I think this is really useful information for growers and agronomists and researchers to be aware of, because by understanding how these diseases might develop or how they might initiate can give you information about how you can best manage your paddocks and your farming system. So both of these diseases can originate from infected seed. from infested plant debris or crop debris. So that might include plant debris laying on top of the soil or standing stubble that might be infested from the previous year. Both of these pathogens also produce these little resting structures. They're very, very small. They're about the size of a pinhead. They're called sclerotia. And they're basically like a little packet of mycelia that can survive in the soil for quite a long time. Some of the literature I saw said around 12 months or 18 months. So, you know, that provides a source of soil-borne inoculum. So then what happens is at some point in the season, we will have fungal structures developing from seed or infested stubble from the sclerotia, and we have the spores that are released in an airborne stage, and that can cause the initial or the primary infection event into our lentil or bean crops. Further on throughout the season, once we start getting more moisture and more humid conditions, or perhaps just cool but prolonged humid conditions, we'll get the initial lesions developing on the plant. Now, these pathogens have a very short latent period of around 3 to 6 days. And the latent period is the time between when the spores have landed on the leaf tissue and before you see the lesions develop. So it's a very short time frame in which to develop disease on your plants. These are also very prolific spore producers. So whilst we might have that initial primary infection event, as we get more disease developing throughout the season, in lentils, we'll have those lentil leaves that might be infected. They might drop down through the canopy, down underneath the canopy into that microclimate where, again, it's optimal for the pathogen to produce infection structures. And then on faba bean, the lesions on the leaves can go from sort of initial, you know, red-brown scattered spots to becoming quite aggregated and expanding. Now, you can sort of see already from these life cycles that these pathogens can infect the crop across multiple plant growth stages. So it will infect from the seedling through the vegetative stage. It will infect at flowering, which obviously has an issue for yield, sorry. If it infects the flowers, they can abort, and that equates to lost yield potential. These diseases, because they're usually associated with spring, they can become a problem when the crops are potting as well. So these pathogens can be present across the whole of that growing season. And so I guess the challenge there is that with these diseases having multiple disease cycles, so they're polycyclic, multiple disease cycles across the season, you could kind of just imagine how many spores can be produced when we've got the right conditions, like we saw in 2022. And then as we're getting towards the end of the season, obviously we're having masses, you know, if we've got a heavily infected crop, we've got massive amount of inoculum present in the crop. And if it's not controlled properly, it does have quite a serious impact on the potential for your yield loss. So if we do have pod infection, then we can have a couple of situations. Either the pods could abort, the fungus could go through the pod wall into the affected and affect the grain, and that can cause either seed staining, which affects the quality of the grain, or it can cause seed shriveling as well, which affects the quantity. So if you end up with seed infected, that provides a source of inoculum for the following year. So you can sort of hopefully understand how challenging these diseases can be for growers to manage. So what are the risk factors? Well, a little bit more plant pathology 101. We have the disease triangle here, which basically says that we only get disease with the right interplay of these three factors. So if we have the pathogen, so that's inoculum on the seed, on the stubble, infested plant debris, or perhaps in the soil are present as those sclerotia, those resting structures. if we have the right environmental conditions. So generally mild temperatures and high relative humidity. And then the one I haven't really spoken much about yet is the host. So a few agronomic factors that can influence or increase the risk of botrytis disease in lentils and beans. That includes a bulky canopy from early sowing, possibly a higher, if you've sown with a higher seeding rate, or where you're growing lentils or beans with a long growing season. And we certainly see challenges with managing chocolate spot in beans in the southeast of South Australia because they have a really long growing season and they're higher rainfall as well. Now, the other factor that's really important for the host, which I've mentioned just briefly already, is around varietal resistance. So obviously, if we have a susceptible variety, they're going to be prone to disease and not be able to resist the pathogen. And by that in turn means that more pathogen propagules are likely to be produced on that crop, which continues to provide a source of inoculum throughout the season if it's not controlled. So varietal resistance in our lentil and our bean varieties. So these are some tables that are taken from the GRDC website for the National Variety Trials. We update the disease ratings for all of the pulse disease, or most of the pulse diseases on an annual basis. There are organisations across Australia that contribute their trial data to this effort. And the pathologists get together and have a debate about the ratings and our trial data. And then those ratings are also debated by the breeders until we come up with this agreed set of ratings for the following year. Now, these are the ratings that were released in usually around early March for both beans and lentils. So left-hand side, we've got the lentil grey mould ratings. And you can see that from the list of varieties there, we've got quite a number of different lentil varieties that growers can sow. And we have resistance ratings that range from moderately resistant, so MR for PBA Jumbo 2, which is towards the bottom of that table, ranging through to S, which is susceptible, so PBA Bolt. So that gives growers quite a number of different options depending on their situation and some of the other traits that are present in those lentil varieties to choose a lentil variety that might have a little more resistance if they're at higher risk in their region. Now, for faba beans, it's a slightly different story. We have a smaller number of commercially available faba bean varieties. And we've got a much limited range of resistance ratings. So this means that there is currently less genetic resistance present in the faba bean varieties for chocolate spot than we do have for lentils. PBA Amberley, which has an MR&S rating, is the best chocolate spot resistance in the faba bean varieties. But I work with Sam Catt, the faba bean breeder, and SARDI provides pathology support to some of the breeding activities in his program. And I know that he's working very hard on finding more resistance with a view to releasing something in the future. So that's varietal resistance ratings. You can download those directly from the NVT website and save that on your phone if that's something that you would like to do. What I'm going to move into now is talking about the 2023 season. So we've talked about the seasonal conditions from last year. We've talked about the high level inoculum that's present and some of the factors that might be influencing disease. What have we seen so far this year? Well, we've got that high inoculum. We've had above average rainfall for June across the southern region. You can see those decile rainfall maps there. Showing quite, above average again, very much above average or highest on record in a couple of spots there at the bottom of South Australia. So, excuse me, this has led to disease initiating and just starting to establish in some crops. So Josh Fanning, the pulse pathologist in Victoria, he tweeted this on the 11th of July about grey mould starting in lentils and vetch in parts of Victoria. And whilst I didn't tweet about it, I certainly had calls around the middle of July as well in some parts of South Australia. And so this was sort of, I guess, you know, kind of a warning about what do we need to be prepared for. However, July, we had very cold temperatures, which again is not optimal for the pathogen. And then we had below average rainfall for South Australia and Victoria. And this is likely to have just slowed the disease progression down. So at this point, I think it's a bit of a watch and wait, especially because at this point in time, there is a forecast for the El Nino conditions, meaning that it's likely to be warmer and drier than average. But El Nino really is a probabilistic scenario. It's not a guarantee that we're going to have warm and dry. But I think the key message really here is for growers and consultants to be alert, not alarmed. And if you can understand the way that these diseases might develop and the sorts of trigger points we might need to be watching for, that'll allow you to be proactive. So what is disease management for botrytis disease in lentils and beans? I'm going to step you through the general recommendations kind of from this time onwards. Because I've already spoken right at the very beginning of the webinar about all of the steps across the whole growing season that you could take. So usually in late winter, we're thinking about that pre-canopy closure fungicide, because as I said earlier, it's the last chance to protect the base of the plants before canopy is closed over and we get that nice humid environment that's underneath the canopy in that microclimate. Now, after canopy closure, or if you don't get canopy closure, the weather really is key. So it's really about monitoring what kind of weather events we're having. Are we having regular rain events? Are we having rain and then sunshine, which, you know, creates that optimal condition for the pathogen? Now, if rain is delayed, we generally can delay a spray to control disease. And control after this canopy closure stage is usually aimed with these three diseases in mind. So botrytis disease, we're usually recommending that you spray ahead of a rain event where there's a forecast day temperature above 15 degrees and the night temperature above 8. Now, there is a new GRDC investment specifically looking at ascochyta and botrytis in lentils and beans that's being led by Agriculture Victoria with a number of different organisations collaborating. So that's just started this calendar year. It's a 3-year project. Hopefully we can refine this advice and give growers some very specific spray strategies for control of botrytis and ascochyta. So then after canopy closure, the other diseases that we might be looking to control for would include ascochyta blight, which this is really the first time I'm mentioning it. This disease is a polycyclic disease, so multiple cycles, and is spread via rain splash. So we're usually looking to control for that disease if it's present and the rain front is approaching, because if we get stem lesions, that can lead to lodging and yield loss. Sclerotinia in the pulses was something that we saw a lot of in 2022. It seems to be driven by really wet conditions and also whether you've got pulse or canola in the rotation and whether you've had sclerotinia disease in the paddock before. So that's sort of your hierarchy in your thinking of what you're looking to control for at this time of the year. Now, potting sprays, they might be required if we have a very wet spring or if you're growing a susceptible variety, because that's all about protecting that developing grain and preventing pot abortion and seed staining. So I've just talked about fungicides. This is really only one of our disease management tools available to us. And it's, I guess, it's the in-season tool that we need to be using. So this is a summary slide of a number of products that are registered or permitted for control of pulse diseases. And what I just want to show you here is that this is the products that are registered for or permitted for control of botrytis in lentil or bean. Now, I've just flagged here for those growers and advisors that prosimidone for faba bean went on to permit in October last year. So it's a maximum of 2 sprays in any season and has a withholding period now of 21 days instead of 9. So you can see there, we've just got a small group of fungicides available for control of botrytis disease. And whether you're choosing to use one of these at any particular time really depends on your specific situation. So let's talk a little more about fungicides. So generally we have 2 broad classes of fungicides. They're either protective or curative. And that's based on the mode of action or where in the infection pathway the fungicide impacts on the pathogens. So protectant fungicides, they act on the leaf surface, preventing the spore germination or infection. Whereas curative or sort of early activity fungicides, they act within the plant tissue and stop the early growth of the pathogen and colonization in the plant tissue. So within each of these modes of action, we have fungicides listed there that have different activities on the pathogen. What I wanted to draw your attention to is the fact that infection from pathogen spores can occur within 24 hours or less of leaf wetness. So this is why spraying ahead of a rain front is the best time for you to put that fungicide out, because you're protecting before you end up with a spore shower. And just remember that even though different fungicides have different label claims about how long they're active for, it might be 2 to 3 weeks or 4 to 6. Any plant growth after the fungicide is applied, it will be unprotected, because once we start to get multiple nodes growing on in the pulses, that will be unprotected. So I know that there was a question in the registrant list about where specifically these fungicides are acting. What I'd like to encourage you to check out is the Fungicide Resistant Action Committee's really cool poster about where these different groups of fungicides, where they're acting on the pathogen. You can access that from that link or Google FRAC and find that. However, we do have a limited number of fungicide actives that are registered for control of the pulse diseases and for botrytis diseases in the pulses. So what's the future of our fungicide identification and development and registration? Well, I've spoken to quite a number of the chemical companies over the last week or so to get their comment, and this is by far the outstanding comment that they are making. Stewardship of fungicide use is absolutely critical to protect our existing chemistries. For the most part, most of the chemical companies don't have any new actives in foliar fungicides available, being looked at or being developed in the short to medium term use. So really protecting the chemistry we have is really everybody's responsibility. Now, it takes quite a long time to identify these new molecules, to develop them and gain the registration. It's a very expensive exercise, and that investment is driven by market share. And unfortunately, pulse production and the value of pulses is pretty small compared to other broadacre crops or in horticulture. I did have a question in my phone calls over last week about what about horticultural products? Well, they're not really very cost effective for use in the pulses, even though it's possible to get permits. And the advice was that they tend to be very specific and targeted. And when we have specific and targeted products, that increases our risk of fungicide resistance. So how does fungicide resistance evolve? Well, I've just swapped out that grassy looking plant there for a faba bean because we're talking about pulses today. Basically, we might have a pulse crop. We're looking at a rain front. It might be the right time of the year that we need to be putting out that fungicide ahead of canopy closure. So we apply our fungicide. Some of the individuals in that fungal population are going to be resistant to certain fungicide actives, and some of them are going to be sensitive and they'll be killed by the fungicide. So once that fungicide is applied, it will control, almost all of the fungal population. But those that survive are, can increase in frequency in the fungal population. And so that fungicide resistance, it might be naturally occurring and present before the fungicide application occurred because we have genetic diversity in our pathogen populations, or the fungicide resistance might emerge through mutation. And applying the same fungicide with the same mode of action repeatedly will enable the resistant population to multiply. So this is something that we need to be really mindful of, given that a lot of fungicides are likely to have gone out on our bean and lentil crops last year for control of botrytis disease. So what's the risk here? So, well, basically, if we have higher disease pressure, there's a higher chance of fungicide resistance developing. So higher disease pressure means that we're more likely to put more fungicides out because possibly there's more disease present in the first place. So the risk of fungicide resistance will be greatest when we have these following characteristics in the pathogen. So short latent period, which we have for botrytis, polycyclic, so multiple cycles of disease throughout the growing season, which we have for botrytis. High spore production, that is certainly possible if we don't control our botrytis disease well, and high virulence, so that's the ability of the pathogen to overcome the resistance present in the lentil variety or bean variety that you're growing. The other characteristic here where fungicide resistance risk increases is where we're using single mode of action or a single group of fungicide that is used repeatedly. And then we've got the host as a characteristic too. So are we growing a susceptible variety where the pathogen population can proliferate because we don't have effective resistance, and where we're growing those that particular crop type in close rotation, so less than that 3 to 4 years. So I've just pulled this. This is sort of a shortened version of that table that I was showing you before with the different fungicide groups, and flagged against each of those modes of action there, the risk that is assigned in the AFREN guide. So you can see that whilst at the bottom of that table, we've got 2 products, chlorothalonil and mancozeb, which are multi-sites. They keep the pathogen guessing by attacking multiple proteins and enzymes and steps in the metabolic pathway of the pathogen. They have a pretty low risk of fungicide resistance developing in response to those chemistries, whereas everything else has a moderate or a high risk. So this is something that we need to be really mindful of going forward, because we don't currently have any fungicide resistance detected in the pulse pathogens, and we'd like to keep it that way. We certainly don't want to be going the way that things have been, the situation for the cereal pathogens. So fungicide resistance management, this is going to look a little bit repetitive, but this triangle is a really great way for you to sort of remember and summarize how to manage for fungicide resistance. So we start with a strong foundation. So that's varietal selection. Select something that's resistant or at least less susceptible, because that will reduce your reliance on your fungicide applications throughout the growing season. Then we go with non-chemical farm management. So this might include stubble management. So I know a lot of growers are moving across to no-till. However, if you have a really high level of disease on your beans from last year and you've left that standing stubble, it might be worthwhile considering burning or grazing or turning that in to help reduce and degrade the pathogen. We've got crop rotation, good hygiene, managing the green bridge over summer to reduce the risk of the botrytis pathogen being harboured on pastures or other volunteers. And then also sowing at the best time to avoid or tolerate disease. And that also plays into not having early sown crops, which can get those bulky canopies. And then fungicide is at the top of this list. We want to use fungicides only when they're necessary and apply them strategically ahead of those rain events, making sure you're rotating your modes of action because that reduces the risk of fungicide resistance developing to any one particular group. Use mixtures if they're available, and stay within the label rate, because that prevents the risk of sublethal doses occurring to the pathogen. So another way of looking at this is what we're calling the fungicide resistance 5. So it's 5 things that you can do. So avoid susceptible crop varieties. Rotate your crops by using time and distance to reduce that disease carryover and allowing the pathogens to degrade on plant stubble or residue. Use those non-chemical control methods to reduce disease pressure, usually around agronomic factors. Spraying only if it's necessary and applying it strategically ahead of rain events, and then rotate and mixing your fungicides or mode of action groups. So just about to wind up, we've got a number of resources that you can access there. The fungicide resistance management guide that's available on the AFREN website. We're just in the process of updating that at the moment, but you can still access that now if you would like to go and have a look. And if you would like to connect with AFREN in any way, there's a few ways that you can reach out to us, as well as the workshops and information sessions and other webinars and things that Cherie mentioned at the beginning. So I do implore you to let your state pathologist know if you see or suspect fungicide resistance. We can certainly coordinate with AFREN to get samples across to them, across to the CCDM at Curtin University to test them for fungicide resistance if we've got those concerns. And that is me. Thank you very much. I'm happy to take any questions.
Thank you very much, Sarah, for a really, really great sort of update and just overall, session with so much info there on pulse diseases. There are some questions. I think you've actually answered the majority of them anyway in the presentation, but perhaps we can just focus in on some of them just briefly. One of the questions was, okay, so what is the best fungicide for pulse diseases? Now, I know that this could be quite a challenging question, but in your opinion, what would be, I guess, I know it comes down to timing as well, but what could perhaps growers or agronomists out there advise on the best one for pulse diseases?
Yeah, so look, I work for the state government of SA, and it is not my role to recommend specific fungicides. And I think really it involves a conversation around your specific situation. So what variety are you growing? How severe is the disease that you're seeing? What fungicides have you gone with already this year? Because if there's certain chemistries you've already gone out with, you probably shouldn't be putting out a second or third of the same product. So look, I've opted today to not present specific trial data because a number of different organisations have done that work, and SARDI is one of them. But I think probably the best information we're going to be able to give you is probably in a couple of years' time, when we've vetted some of these different spray strategies as part of that new GRDC investment, because we're looking at both the timing of application as well as specific chemistries in rotation with others.
Great, thank you. Another quick question to throw to you, Sarah, is what is the value of an early application of tebuconazole for chocolate spot in faba beans?
Yep. So tebuconazole on its own is actually not registered for control of chocolate spot in faba bean. It is one of the actives present in the fungicide product Veritas Opti, and that's present with a strobilurin. So we do need to be careful about applying a tebuconazole and expecting chocolate spot control. What I do find, and this is anecdotal because I don't have the trial data to support this, what we do find is that usually growers who are putting a tebuconazole spray out around 6 to 8 weeks after sowing, and often it's going out with their grass spray, they're likely to have less issues with chocolate spot later in the season, and that's because you're controlling for Cercospora leaf spot. So Cercospora leaf spot is a soil-borne disease. It's usually an issue where we have long-term faba bean cropping. and it can survive in the soil for sort of 6 to 8 years. So I guess the advice is that if you can keep your crops clean early, your risk later in the season will be reduced, especially if we have a wet spring.
So since there is really not any resistance that has been documented, right, as of yet, do you think that perhaps farmers, agronomists and so forth could tend to be a bit more relaxed with these crops? And, you know, obviously it shouldn't be, but do you find that may tend to be the case?
I'm not sure that I would describe farmers as being relaxed around their disease management and need to control for disease. Some of the consultants I've spoken to have certainly said that growers have a zero tolerance for disease these days, especially because there's a number of great products out there. I think the more that we can get the message out to pulse growers through, you know, platforms and avenues like AFREN, the better educated we can and sort of better informed we can make the industry, because we don't want fungicide resistance in our pulse pathogens. We're seeing how troubling it is for wheat, you know, with fungicide resistance in powdery mildew and some of the others. So I don't know, Fran, is there any other comment that you would like to make in that space?
I think that the pulse industry is really fortunate in the sense that, you know, they've got multi-sites. And these multi-site fungicides, I know that, you know, that using these compounds, you know, logistically, you know, it can be a bit tricky. So that's why, you know, we like systemics, right? So we can have them, you know, in the plant for a longer time when it depends on the weather. But, you know, this multi-site really, what is allowing the industry is to control diseases in a way that if there is resistance evolving, the use of these compounds is gonna reset the system. And the reason for that is basically on the slides that Sara was presenting earlier. So she was alluding to the point that these compounds, multi-site chemicals, like for example, chlorothalonil or meturam or mancozeb, so these compounds, there is no resistance documented in the field. And the reason for that is because these compounds, they are targeting multiple different enzymes inside these pathogens. So by having them as part of your chemical programs, so you're protecting any other chemicals, like for example, chemicals from the group of 11, azoxystrobin, or chemicals from the group of the SDHIs, group 7. So using these multi-sites is paramount and is fundamental for maintaining, you know, this stewardship around these other products. So for as long as we can maintain them in the system, we will probably be seeing, you know, how the pulse industry has a slower rate of fungicide resistance development compared to other industries where these multi-sites are not present.
Okay, so just a final recap. Which systemic fungicides have the most reach back for established disease levels in our pulses?
Oh, that's a good question. I don't have that actual data. Fran, I don't know whether you have that specific information. I mean, I hear a lot of anecdotal reports about some of the newer fungicide products seem to perform better than some of the older products, but I don't actually have data to support, to sort of speak to.
If I can make just a quick comment, I guess that the answer probably really depends on the disease that you're targeting. If your target is chocolate spot, traditionally, for example, DMIs, group 3, have been very effective at that sort of a, you know, kickback action effect for all the diseases, but not so much for chocolate spot compared to, you know, some of the new chemistries that Sara was referring to. So if that's the target disease, considering, you know, the activity of DMIs on that disease, so probably we're talking about SDHI, but again, you know, I don't have that specific data with me either. So, you know, that's probably a question to the companies that are commercializing those products, and maybe there is some data out there that we can facilitate, but we don't have that data reach at the moment. What is clear is that a contact chemical, a multicide, has no kickback action. So if you've got the disease already in the plant, the contact chemical, as Sara was saying, you know, with her slides, or illustrating with her slides earlier, so the chemical is going to be outside the plant. So if you've got the disease inside, you're not going to be able to cure it.
Now we have had one final question come through, so if we can maybe just quickly address this. It's reads as how quickly could farmers identify the pathogens in terms of, you know, developing resistance or loss of sensitivity to a particular chemistry, but without them suffering significant yield loss, if that makes sense.
So the question is how quickly can a grower identify the disease or the fungicide resistance?
It appears to be resistance. Oh, how quickly farmers could identify the pathogen, or identify if the pathogen has developed resistance or sensitivity.
Yeah, so I guess that would be something that we would require samples that would need to be sent to CCDM for testing. And that's probably how long is a piece of string question.
Yeah, absolutely. I guess that there are two levels there. So how quickly you can identify that in the field, so that probably, you know, comes down to how thorough you are with your monitoring. So if you know that a compound is going to be offering this level of protection, and under, you know, similar conditions, you're basically getting half, and you're positive that your application has been okay, so you didn't have issues with drift, canopy penetration, nozzle size, runoff, so you probably can be quite sure that you've got some decline in the activity of that compound. Then it's up to, you know, collecting samples, getting in touch with Sara, or, you know, your normal contact within the industry, and getting the samples tested. But the first step is you making sure that your application was fine, that you are not, you know, it's cutting some corners there, and then, you know, just making that assessment and then just getting sample tested. So an analysis, if it is coming from a paddock, you know, with a high concern of resistance, so it's normally quick. So it takes a little bit of time for the samples to come over here towards Australia, but once the samples are here, so the analysis is normally, it's relatively quickly, especially if there is that information, right? So if there are, you know, some concerns about, you know, the possibility of resistance in that paddock, okay?
Well, I'm going to close the session now. So thank you, Sara and Fran, for delivering this update on pulses and their respective diseases that serve not only to inform farmers and agronomists, but also the wider industry, particularly when we think about the awareness that is needed to recognise that, you know, there is potential for resistance to develop also in these crops. I want to thank Bridget and David at Ag Communicators, and also a huge thanks to your team for organising this webinar. As we bring this session to a close, there is a survey link that would have appeared in the chat box. We would really appreciate your feedback on the session. So from the team here at AFREN, we would like to thank you for joining us today. Take care, and we hope to see you again in the future at another AFREN event. Thank you.
Thanks, Shuri. Thanks, everyone.